Good morning, everyone. We're essentially today going to be working on our last chapter for this week's homework. And we'll get this finished, obviously, by Friday, so I'm not too worried about time. When you go into the details of how do you estimate the difference in two population means, and we're going to do quite a lot by hand and some with salt. So here's a little story about the average ages of two populations. So imagine we have population 1, which I'm picking as Scotland, and we have population 2, and in population 2 we'll choose, just because I want to, we'll pretend it's Brazil. And so we're interested in, is there any difference between the average age of people who live in Scotland and the average age of some other country like Brazil? When you talk about things like population, they very often use the word demographics. So they talk about the demographics of a country. They're really talking about how many 70-year-olds live there, how many 20-year-olds, how many teenagers live there, what's the average age. You know, they're looking at things to do with the age of people who live in their country, typically. But you can have you can have, I've forgotten the word now, I've just said it. You can have it of cities as well, the demographics of a city. I mean, you could find, for instance, that the demographics of Bremerton are quite young. And the reason I'd make that as a prediction is that doesn't Bremerton have an awful lot of Navy personnel who are still active, right? Lots of submariners and so on. And they typically don't tend to be 50 plus, right? Don't they tend to be, you know, young 20s? And so there's a large enough group of them. What would probably make the demographics of Bremerton quite young, whereas maybe the demographics of, oh, I don't know, a city in the top of my head, demographics of Miami in Florida might be quite older, because a lot of people retire in Florida, right? So they have a lot more older people there. So those are the kind of things that we're dealing with in this story. Now, superficially, would you agree it looks like Scottish people are older in general, right? The average age is a little bit older. And we are going to try and find if that's true. And there are two sentences down here, which I think I figured out the code words that WebAssign uses. If they say use the empirical rule, I don't think they've said it this way, but if they say use the 68, 95, 99.7 rule, which is the same name as the empirical, right? To get a 95% confidence interval, we're going to do one type of formula. And if they just say find the approximate 95% confidence interval, we're going to use the other. So let me show you in kind of vague way what they're getting at here. If it's a 95% one, the formula is going to be the mean of the first group, the mean of the second group, plus 1.96. This is for 95%, right? Times the standard error. And if they say use the empirical rule, the 95% confidence interval is going to be almost identical. Can you tell me what's the difference? I won't use 1.96. What will I use if I'm going to use the empirical rule to generate a confidence interval?
2.
What? 2. Now, can you imagine in a lot of questions, won't these two answers probably round off to be the same number? Unless it's like 6 decimal places. So couldn't you accidentally use the wrong formula, but still get the right answer, right? So there's a fair amount of wiggle room between those two. But as far as I can tell, because I did some questions where I did it with a 2, and I did the question where I did it with 1.96, it looks like the empirical rule might be working here, right? Now, if I end up being wrong, because I only did a couple of questions, then it's this number I should have used and not that one. So it's not a hard one to fix, right? So if the first one doesn't work, you can say, okay, I'll try 2 then, right? Or vice versa. So let's return back to our story, because apart from the magic number, everything else is going to be pretty much what you see is what you get. So here are my 2 populations. Let's find the standard error. And it doesn't matter really which of the 2 we use. It's the same formula for the standard error. And it's essentially this guy. Of course, you will see this guy sometimes. So let's talk about what's going on here. If you use the letter S, S1, S2, if you use S, it's the standard deviation of the sample. And if you see a sigma, it's also the standard deviation. But the standard deviation of what? S is the standard deviation of a sample. What is sigma the standard deviation of?
The population.
Yes. So if they say you did a sample and sigma is 10, or you did a sample and S is 10, would you agree it's the same number that's going to go in the formula, right? So it's not really a biggie, right? So if they say sigma is 10, 10 squared, whatever. If they say S is 10, it's 10 squared, whatever. It's not going to change really anything significant. So here is this guy. And this fella is 5. So 5 squared over 150. And this guy is 3.8 squared over 205. Now, to use this formula, in fact, to use the whole formula that we're going to be doing, we're making an assumption here that both populations are essentially normal in shape, right? Bell-shaped, symmetric, right? And that's a fair assumption to make in many situations. So let's see what we get. We have a square root. We have 5 squared divided by 150 plus a 3.8 squared divided by 205. And I get the answer 0.487. And I'm doing this to 3 decimal places because the answer has to be to 2 decimal places. So if they ask you to find a confidence interval to 2 decimal places, don't you make sure that all your calculations are at least 3 or 4, just to be safe. So far, so good? Right, so let's do the approximate one first. So the approximate 95% confidence interval is going to be the difference in the means plus 1.96 times the standard error. And the difference is going to be 30.2 for the Scots, take away 29.1 for the Brazilians, plus 1.96 times 0.487. And you take this guy away from that guy, you get 1.1, I believe. And if you multiply these two together, you get 1.96 times 0.487. And the answer is plus or minus, I forgot my little minus, plus or minus 0.9545, just to be extra accurate. So I'm going to take that and subtract this. So 1.1 take away 0.9545, and I get the answer 0.1455. And I'll take this guy and add it, and I get 2.0545. And then to two decimal places, 0.15 and 2.05. Are we comfortable about, rounding off at the end, doing more accuracy up to that point? So we can be 95% confident that the true difference in the population ages of Scots people compared to Brazilian people is somewhere between 0.15 and 2 years. Agreed? Now, there can and there will be some extra bits. Is there enough evidence based on this interval to say that Scottish people are actually older, on average, than Brazilians? Now, the way you tell is by looking at this interval. Have you noticed that the interval is all positive numbers? And if the interval is all positive numbers, doesn't that mean that the first thing is bigger than the second? So yes, this is evidence that Scottish people are, on average, older than Brazilians. Not by a lot, right? Could be as much as 2 years on average, right? But it's, even if it's only a month or 2 months, it's still, on average, they're older. What would it be if we got an interval and it looked like that? Right, this would mean Scots people are older than people from Brazil. What would happen if the interval had negative and positive numbers in it? We call that contains zero interval. What would that tell us, if anything?
There's not enough data to tell.
Exactly. You phrased it a good way, actually. Right, there's not enough data to tell if there's a difference. There might not be. I know it didn't happen in this one, but can we pretend that we actually got a whole load of negative numbers in my interval? Because that's the three things that are going to happen, right? All the numbers are, both numbers are positive, right? Everything in the interval is positive. The interval contains zero, right? Some negative and some positive. And the third possibility is that the interval has nothing but negative numbers in it. What is the conclusion you come to if that's what your interval looked like?
That the second one is older, so Brazil would be older.
Right? And you could say Brazil is older than Scots, and that's totally correct. And can you also just say Scots is younger than Brazilians, which is the same thing? Agreed? Logically. I actually know the answer to this because I know some weird stuff. Do you know what the truth is? The demographics of Scotland compared to the demographics of Brazil. Do you know which one does have the youngest average age? Do I have a guess? What's your guess? How can you get a guess wrong? Right? You can't get a guess can't be wrong. It's a guess, right? I'm going to ask you then. If you're not going to tell me, I'm going to just have to ask for a volunteer. Isabella, do you think Brazilians are younger or older than Scots people?
Younger.
They are. Significantly so, right? The demographics of Scotland is very similar, but not worse than most of Western Europe. Most of Western Europe, the average age is increasing. Right? The demographics are quite bad. One of the worst countries in the world for demographics is Japan. Japan's average age is really quite old. Compared to Brazil, there's like 15 years difference. Brazil has a large population of very young people, and it's caused by large family sizes and, lots of kids, younger age group, and just the sheer demographics of Brazil. Really a lot of young people in Brazil. Scotland's very old. A lot of Scottish people are old or older. Population, family sizes are quite small, so there's not many children. That tends to drag it down. America is better than we are in Scotland. You're better than most of Western Europe. I think you're probably equivalent to Canada, but Mexico and anywhere else in the south of America has a much higher, are a much younger population. Now, it might not seem too bad an idea, but one of the problems with demographics is, let's take Japan. Japan is going to be in real trouble in probably about another generation or two. You're going to have a country where something ridiculous, if you want to use that word, like 40% of the population will be too old to work, which means the other 60%, and that isn't the whole lot, because some of those 60% are still babies, right? They're always going to be babies and kids at school. They won't be working. So can you imagine a country that is trying to support the health service, you name it, social nets, the whole thing. Japan is in real trouble. Another country that might surprise you who is in real trouble, China. They're not as bad as Japan, but China had that one-child policy for a really long time because the population was huge. And I think it's been going on for about one, maybe two generations, that rule. But that rule has really drastically reduced the young population in China. And there's going to be a bubble that they're going to have to go through, well, after I'm dead, but there's going to be a bubble that they'll have to go through where they're going to have to handle a huge number of very old people and not enough young people to sustain them. So I'm glad that there's Isabels in forests, because when I start retiring, it's you lot are going to be paying my social security money, and it's some of you lot that are going to be in the hospital when I have to get my checkups. So, hey, it works for me. Yeah, are we cool with that question? The process of how we did it, right? So let me find one that they've got that just makes your life a little bit awkward, or a lot awkward. So here goes. I'm going to cut off the solutions here because they distract the heck out of me. And let's go in and see what we got. The answers are still there. Go away, answers. It does it automatically. I wish it would stop doing that. Right, here we go. Here is eggs. Eggs are important for many people's diets. I think the guy who wrote this was getting money off the chicken company. There seemed to be a lot of stuff about eggs lately. Wasn't there one about protein and stuff yesterday? Right. Anyway, eggs, chicken, good stuff. Different types of chicken feed can impact the weight of eggs. Okay, so you could buy brand A chicken feed and brand B chicken feed, and the chicken farmer tries out one and then he tries out the other, and he's figuring out, well, I get more money with bigger eggs, right? Which one works? So here is the following represent egg weights in grams from 10 of his chickens. There they go. Find the mean weight. Do you know you're going to have to do that by hand, right? How would you get the mean weight of 10 chickens? Just tell me how you do it.
I did the statistics, the table we were doing towards the beginning of, I just entered them all in the calculator and found the mean that way.
Okay, so you can use it on your calculator. Remember we did that way back week 1, I think it was, right? You might have to go and dust it up. I'm not even going to do this question. Can we pretend the answer is 53.4? Just pretend it is, right? That gets that question out of the way. Now, here's someone who's been really nice to us. Can anybody remember what mu means? It's a mean. And we've already mentioned this guy, sigma. Have you seen that all they're saying is, look, this is egg producer number 1, right? And the average egg weight is that number, mean, and the other one. And the standard deviation is this one, and the standard deviation is that one, right? That's what sigma is, right? And the only one that kind of makes sense is the sample sizes. Would you agree they're normal numbers? Now, a random sample of 35 eggs is selected from producer 1 and 45 eggs. Well, you don't need to tell me that, it's in the table, right? Find the difference between them. Well, won't that just be 52.3, the first one, take away 54.6, the second one? And that's going to be a negative number, so bear with me while I do that. 52.3 take away 54.6. And the answer is negative 2.3. That's basically saying the first one is about 2.3 less than the second. I think you can see that, right? There's the first one. Isn't it a little bit less than the second? By how much less? By 2.3 less. Now, it then goes on and just asks us for the standard deviation. Now, if you want to do the standard deviation, isn't it going to be square root? Well, I'll put in what I can. It's going to be the square root of that guy squared divided by 35. So that's going to be 9 divided by 35 plus that guy squared divided by 45. So that's going to be 1 squared divided by 45. Oops, I'm there. I rub it out. 1 divided by 45. Big fat fingers. Right, so that's whatever that is, right? 0.1234, you're finished. Now, do you notice in that question, you're not even calculating confidence intervals yet, right? They're just getting you used to doing bits of the calculation that you need. Now, this one, however, does the whole thing. So we have 44 guys. I'll write this down and then I'll go to paper in a minute. So we've got population 1, which is the head circumference of men. Is that males? Yeah. Okay, males is going to be population 1. Females is going to be population 2. And 44 men, right? So the sample size is 44. And the mean is 57. And the standard deviation is 1.5. And for the women, there's also 44. And the mean is 54.5. And the standard deviation is 2.2. And we are going to do an approximate 95% confidence interval, right? So this should be a plug and chug. We've got all the data. I think superficially, aren't guys bigger headed than women? And a lot of the women are being very sexist and nodding their head and saying, you're right, men are big headed. You were thinking that, weren't you, Cheyenne? Men are big headed. Okay, it's probably
It's all that bone so we can crush beer cans on our heads more efficiently.
Oh, you're not helping here. Have you ever noticed that society is very one-sided? you are allowed to insult males and no one would ever pick you up and say, oh, you sexist. But if you said something equivalent about a female, wouldn't you be branded as being sexist? Isn't that just unfair? Shouldn't I be able to insult both of you equally well and not get branded? No? Okay. All the data is here. I need to know a couple of numbers, but the important one is the standard error. So it's going to be S1 squared over N1 plus S2 squared over N2. Couldn't I call that sigma 1 squared and sigma 2 squared if it made you feel better, right? It's still going to be these two numbers. So it's going to be the square root of 1.5 squared over 44 and 2.2 squared over also 44. Okay. So the calculator takes over. 2.25 divided by 44, add 2.2 squared divided by 44. And what do they want anyway in accuracy here? Oh, they want it to the nearest tenth, which means 1 decimal place. So I'm just going to write that much down. So when I'm finished, my answer is going to be the nearest tenth, 1 decimal place. But right now I'm doing it to more accurate than that. So we're ready for our 95% confidence interval, which is that guy, plus or minus 1.96 times the standard error. And if you take 57 and subtract 54.5, and then you add and subtract 1.96 times this guy, we should be close to the answer. So it's at 2.5 plus or minus, let's see what we have, 1.96 times 0.401. And I'll try that again. 1.96 times 0.401. And we get plus or minus 0.78596, doing my overkill thing. Take that away. And so 2.5 subtract 0.78596, which is overkill. You get that. And then if you add them together, 2.5 added all that mess, we get.
I see what you mean now by when you said that we could use the wrong formula and still get the right answer. I used the empirical.
And the numbers were so darn close it didn't matter. Yes. Yeah. Occasionally you might be a little bit out, but it looks like 1.73.3, right? If you round it off to 1 decimal place. So we're cool. They don't have this. I wish I had a little bit. Is this enough evidence to prove that guys do have bigger heads than women? And no, it doesn't mean that their heads are thicker bone for smashing beer cans, but it might. But that would have to be a different story. I have a horrible joke that's came into my head, so you're going to have to suffer it. So it's out. Forrest, they just heard that Hitler was Irish. You know what I heard about that? Hitler was Irish. And what happened is that they found his original birth certificate. He was born in Ireland. And he wasn't called Adolf Hitler. His name was Richard Potato. But when they moved to Germany, he changed it to dictator. Bad? Okay, let's keep going. Right, so would you agree that there's enough evidence that there's enough evidence that males have thicker heads than females? Why do I know that? Aren't the intervals all positive? And if they're all positive, the first thing, males, is bigger than the second thing, females. And that would have been a nice part D to that question, but they didn't do it. So let's move on to our next question, which is going to be a version of question 4. So this is a survey they done with students, and they answered questions about alcohol use and hangovers, including a count of how many out of a list of 13 possible hangover symptoms they had. So they went and said, okay, were you dehydrated? Did you have a headache? Was bright lights painful? You know, whatever the list is, right? They went through it, and evidently I didn't know that. There are 13 hangover symptoms. I can't think of 13, but evidently there are 13. Maybe you felt nauseous or something, right? And, oh, they're being sexist again. We have men, and in the men group, there was 470 of them. And if you didn't get drunk, your answer was 0. But on average, they suffered 5.6 of those 13 symptoms. And the second group is going to be women. And in this group, there were 755 of them. And only 5.3 symptoms. And let's find out what the standard deviation is. Somewhere in this story, and the standard deviation was 3.1 in both cases. Okay, go for it. Find a 95% confidence interval, and I'm only giving you 3 minutes, so the pressure is on. Go for it. I'll set up the formula for the standard error. And the formula that you'll be using and they want the answer to 4 decimal places, but don't worry if you do it to 2, just do it to 2. We're just going through the process. I'll probably do it to 2 as well. And while that's happening, I'm off to see why my dog is not here. She's always up to no good. Last minute.
Got it.
Got it. Last few seconds. Got it. Okay. Didn't give you a lot of time, so don't feel bad if you didn't quite finish it, but you can finish it as we go through it. So standard error, this guy plus this guy. I have 0.18. I know you could go on forever. We're going to finish with 2 decimal places, but I'm going to do everything else to 4. So there's 0.1821. Does that look about right? You get a standard error, it looks something like 0.18 and right.
Yeah.
Okay, so that means this here goes here. And this guy is 1 take away the other. I'll just do that in my head, so it ends up being 0.3. So let's find out what these two guys look like. If you do a 1.96 times 0.182, and the answer I'm looking at is 0.3 plus or minus 0.36. So on this side, it's negative 0.03, and on this side, it's 0.66. That means because it contains the number 0, right, it's positive and negatives, that means there's not enough evidence to prove that men have more hangovers than women, right? Not enough evidence to prove it. And that's the end of that question. So let's look at our last question for today. And that one is on website. So this is data on the testosterone levels in saliva of men in different professions were given in a paper. So someone did a research paper and they were looking at different professions and what the average testosterone level would be for those kinds of professions. And the researchers suggest that there are occupational differences in the mean testosterone level. Okay, so if you think of testosterone as it's obviously it's a hormone that both men, male and females have, but males just have a lot more typically. I can believe that's true. I bet you if you got the testosterone level of, I don't know, boxers and wrestlers, they'd be really high. And if you got the testosterone level of males who worked in kindergarten with kids, they're probably lower. Would that seem reasonable? You wouldn't want some really aggressive person working with little children, right? I think that's probably not the career you should do, right? So I can imagine there are differences. The group that they looked at were actually doctors and professors. And the sample was very small. There were 16 here and 10 here. And they tell you all the key numbers. There's the mean. There's the standard deviation. That's the professors, and that's their standard deviation. And the difference between them is 1.1, which you could do right now. Couldn't you just take those and subtract them? So that's where that came from. And they even did a confidence interval for you. And they told you this thing called degrees of freedom. So pretty much, I don't need that button yet. In fact, pretty much everything I need to know is in that table, isn't it, somewhere? Almost everything you could possibly want. And there will be some missing pieces. Now, the 95% confidence interval was that. and it used what was called an unpooled procedure, which is typically the one that we are using to compute the interval shown. Which of these formula gave you that answer? Right, there are 5 guys there. Which one of them looks closest to mine?
4.
4. Now, do you see that they've got a little guy called T star? You see that? Is it not a placeholder for the 1.96 or the or the 1.645 or the 2.58? Now, it is called the T because evidently, whoa.
Okay, metal stuff.
Let me kill
right away.
something. There we go. Got background. Oh, there we go. Right, so what was I saying? Yeah, they're making an assumption here, which is quite valid, that remember that you use T distribution. Remember the guy who did the Guinness? You should only use that, right, when the samples are really small, or that the distribution isn't nice and normal. And they are looking on the assumption, which I think is totally valid. Would you agree 16 and 10 are very, very small samples? Now, if that was 1,610, 10,000, wouldn't you be using Z star, which is what 1.96 is? So that is a minor difference. So, but that's the right answer. Now, they talk about a thing called the statistic, a standard error, and a multiplier. So let's tell you what each of those guys are. Do you see the guy that was the difference between them? What we would have called X1 bar take away X2 bar. That is a statistic. So in this case, 1.1. And the standard error is nowhere to be seen because it's missing. That means we're going to have to calculate the standard error. And so I'm going to nip back to my whiteboard. And we'll have to calculate it. Well, isn't that going to be the square root of S1 squared over N1 plus S2 squared over N2? And although you can't see it, I can. That guy had a standard deviation of 3.38 squared, and the sample size was 16. And the professor's was a 2.56, and that was out of 10. So to get the standard error, we would do the square root of 3.38 squared divided by 16, add 2.56 squared divided by 10. And I can't remember what accuracy they want, so let me go and read it. 2 decimal places it is, okay, so how about 1.17? So I'm now going to go back and kind of fill in 1.17. And then they've got a guy called the multiplier. Now, that multiplier would have been 1.96 if we were doing a normal distribution, right? A Z-score. But it's a T-score. And this is the first time that we've had to find this guy. The multiplier is the name you give to the multiplication next to the standard error, right? So the 1.96, the 1.645, or whatever it is. Now for the T distribution, that number changes depending on this fella here. You see that degrees of freedom guy? 22. Right. We are going to go hunting, and I am going to use the salt button. And I'm going to go over here. And I'm going to do, can I do it with 2? I think I should be able to do it with 2. Right. And Darn it, I should have written those numbers down. Sorry about that. I've just noticed something. I don't need to do so. I can do it another way. Oh, I can do it two ways. I'm daft. I want to use the interval that they've gave me, and I also want to use so. And I don't have time to do either, so I'll do the quick one first, and then next time I'll show you the longer one. Okay, so this is how I'm going to get the answer. I already know what the interval is. It's negative 1.33 up to 3.53. Now I know what x1 bar take away x2 bar is. We already know that is 1.1. So what I'm going to do is I'm going to go 1.1 and I'm going to figure out what you need to add to get that. And you need to add 2.42. Right? If you add them together, you get that. And I bet you if you take it away, you get that guy. So what I've now found is the margin of error. Now, isn't the margin of error the magic guy times the standard error? And I know that that's 2.42. I know this guy is 1.17. Divide one by the other, and there is your answer. And I have someone at the door, so last name and bye-bye, guys.